Okay, so this is part one of the test review. This is the review for the first part of the test we'll be taking on Thursday. So the first problem we're going to look at is solving an absolute value inequality and graphing it on a number line. So this is when we have one variable. So for these types of problems, we need to set up two inequalities. We have two cases. The first case, all we have to do is drop the absolute value symbols. So we'll have negative 2x minus 3 is less than 5. The second case, we drop the absolute values. So we'll have negative 2x minus 3. We flip the inequality, so instead of a less than, we are going to have a greater than symbol. And we change the number on the right side to a negative. Okay, so first case, drop the absolute values. The second case, we drop the absolute values, flip our inequality, change the sign of the right side. And then we're just going to solve both of these down. So we will start by adding 3 to both sides. We'll have negative 2x is less than 8. And then dividing by negative 2. Remember, when we divide by a negative, we have to flip the inequality. So we get x is greater than negative 4. For the second one, same steps, adding 3 to both sides. We get negative 2x is greater than negative 2. And then dividing by negative 2 on both sides. And again, since we divided by a negative, we flip the inequality. So we'll end up with x is less than positive 1. So x is greater than negative 4 and less than 1. We're going to graph those on a number line now. So I need to number the number line. So I'm going to say, we'll start at negative 6. Okay, so I've graphed my number line. I'm going to start then by plotting my first point. So x is greater than negative 4. It's going to be an open point because of the greater than symbol without the equal sign. And if we don't have an equal sign, it's an open point. When we have the equal sign under the inequality, it's a closed point. So an open point at negative 4. And these are all the numbers that are greater than negative 4. So I'm going to be going to the right. And then for the second one, x is less than 1. So again, open point. And it's going to be an open point at positive 1. And these are all of the numbers that are less than 1. So that means I'm going to be going to the left. So our final answer, since these overlap, this is an and statement. Our final answer is this section only. So we're just going to shade that in. There we go. Okay, so the answer is just the numbers that are in that intersection, not including the 2 points because they are open points. Okay, next we're looking at solving the inequality and then graphing our solution set on the number line. This is again a one variable inequality. So I'm going to treat it like an equation. I start by subtracting 7. So I get 3x is less than 9. And then dividing by 3. So setting up my number line again, I'm going to number it. Okay, so I've numbered my number line, and again, this is a less than symbol, doesn't have the equal sign. If it doesn't have that equal sign under it, it's an open point. So I'm going to plot an open point at positive 3. And then this is all the numbers that are less than positive 3, so I'm going to be going to the left. And I just shade that in. And that's it. Okay, so for our next problem, we're solving the compound inequality. This is an and statement. You can do this one of two ways. You can either do what I'm about to do. I'm going to take this and I'm just going to cover up one side at a time. Or you can take it and break it into two inequalities. The first inequality, we're just going to cover up the right side. My first inequality is -3 is less than 2x plus 5. The second inequality, I cover up the left side. So my second inequality is 2x plus 5 is less than 17. So we can solve these separately and then graph them, or you can solve it all as one single inequality. Okay, and I will show you how to do it both ways. So for the first way, I would solve these separately. So I would subtract the 5 from both sides. I end up with -8 is less than 2x, and I divide by the 2. So I get x is greater than -4. And remember, we want the x to be on the left side. When we flip these around, we have to remember to flip the inequality as well, okay? So if the open mouth was facing the x in my answer, when I flip it around and the x is on the left side, the open mouth should still be facing the x. And then I would solve the other one, same way, subtract the 5. 2x is less than 12, and divide by the 2. So x is less than 6. Okay, and then I can graph both of these and see where they intersect. It's an and statement, so they should intersect. Okay, so I'm going to number my number line. Okay, so I've numbered it. I'm going to start by graphing the x is greater than -4. It's an open point at -4. All the x's that are greater than -4, so I'm going to the right. For the second one, x is less than 6, so starting at 6, open point again. And that's all the numbers that are less than 6, so I'm going to the left. So my answer is the intersection of these two pieces. So I'm going to shade in, darken it, to highlight the actual answer. Okay, so that is one way that we could do this type of problem. Splitting this up using, you don't even need an actual block or anything like this. You can just use your hand or something and cover up each side. So you're breaking this into two separate inequalities. So one where -3 is less than 2x plus 5. The other one where 2x plus 5 is less than 17. That's one way to do it. The second way, we're going to erase everything that we have here. Okay, so the second way to do this is to solve the entire inequality. Whatever I do to one of the sides, right here I have the middle, the left, and the right. If I do something to the middle, I have to do the same thing to the left and the right. Okay, if you don't want to have to break it up, this is another way to do it. So we could subtract the 5. We're trying to get the x by itself. So to isolate the x, we need to get rid of that 5. We need to get rid of the 2. If I subtract the 5 in the middle, I have to go over to the right side and subtract the 5. I have to go to the left and subtract the 5. So -8 is less than 2x, which is less than 12. And then trying to get rid of this 2, I divide it. If I divide the middle by 2, I have to go to the right side, divide this by 2, and go to the left, divide the left side by 2. So I end up with -4 is less than x, which is less than 6. And then I would go ahead and number my number line like I did before. Okay, so I've numbered my number line. I'm going to go ahead and graph my inequality now. So open point at -4 and an open point at +6. And the nice thing about doing it this way is that I can clearly see this is an and statement. It's going to be an interval between these two numbers. So after I have those 2 points graphed at an open point at -4 and an open point at 6, I'm going to shade in everything between those two numbers. So it kind of cuts out the work of graphing each inequality separately and then finding the overlap. And that is our final answer. Okay, so next we're going to look at scatter plots. So the first thing we're going to do is plot all of our points. So we're looking at the years of experience versus the yearly salary. So we're going to plot these as x comma y. So for my first point, 0, 25, I'm going to go to 0 up to 25, plot my point. The second point, 0, 30, so I'm going to go to 0 up to 30, plot my point. Okay, 5, 35, go to 5, up to 35, plot my point. So I'm just going to plot the rest of the points in my table. Okay, and now I have all my points plotted. I'm going to go ahead and draw in my trend line. So letter A is finished. Just going to check that off. I drew my scatter plot. Letter B, if one exists, draw my trend line. Obviously there is a trend in this data. It's going up from left to right, and it's going up almost in a perfectly straight line. So drawing my trend line in, and I'm going to use actual line. Okay, so remember trend line, we're trying to get it as close to the points as possible. The points do not all have to necessarily be on the line. Sometimes none of the points will be on the line. Oops. Alright, so I'm just going to kind of move this around until I feel like I have the best line here. Okay. Alright, so I'm hitting about 3 of my points, and there's 3 points above my line, 2 points below my line. This looks pretty good. Okay. If yours was a little bit different than that, that's okay. The trend line is just an estimate, so it should be something like this. So that is letter B. Okay, so letter C, we're estimating the salary for, whoa, not 85 years. That's way too much. Don't know why it says that. Okay, we're estimating this for, we'll say 23 years. So what we're going to do is look at my x coordinates. These are my years of experience, and I'm going to look where it says 23 years. So 23 years right about here. The y coordinates then, I want to check how much money, how much the salary would be for 23 years. I just go up to my trend line, and it's just slightly above the 85, right? So we'll say that's close to 86,000. Okay, so according to our trend line for 23 years of experience, it looks like it would be about, and we'll say 86,000 because it's just above 85. And then finally, the last question is asking just to describe the correlation. So it is going up from left to right, and it's going up in almost a completely straight line. These points are really close together, and it's very linear. They're not, we don't have points that are way up here or way down here. They're very straight. So that means that it is a strong positive correlation. It's strong because it's in a very straight line. It looks very linear. The more linear it is, then the stronger the correlation is. And it's positive because it's going up from left to right. Okay, so graphing a piecewise function. A piecewise function we graph in 2 separate pieces. So graphing the first piece, we've got 2x minus 1 if x is less than or equal to 1. So to graph these, we are making tables. We make a table for each piece. Okay, so I'm going to say this is going to be my red table. And my second function will be my blue table. The first number in our table should come from the domain. So the domain for my first one is x is less than or equal to 1. So I'm going to choose 1 as my first point. The next point from the table should also come from the domain. It's going to be any number that's less than or equal to 1. Something that we could plug in for x that would make this true. So any number that's less than or equal to 1, I'm going to choose 0. After I choose my 2 x values, I plug them into the function to figure out what my y values are. So if I plug 1 in here, 2 times 1 minus 1 gives us 1. If I take 0 and plug it in, 2 times 0 minus 1 is negative 1. For the second function, I'm using my domain, so I start with 1. That should be my first point. The second x value comes from whatever can make the domain true. So x is greater than 1. That means I need to choose a number to plug in here that'll make this true. So any number that's greater than 1, I'm going to choose 2. And then just like the first table, I take these and I plug them in. So if I take 1 and plug it in, 3 times 1 plus 1 gives me 4. If I take 2 and plug it in, 3 times 2 plus 1 gives me 7. So now I'm ready to actually graph my function. So for the first one, I'm going to look at the first point. The first point in each of my tables are special, okay, because I need to determine if it's going to be an open or a closed point. All of the other points, if I wanted to put more points in my table, our second point and beyond are always closed, but that first point is going to be either open or closed. I can tell by looking at the inequality. So for the first function, it's a less than or equal to, so it's going to be a closed point. That equal to symbol means closed. So I'm going to put a closed point at 1, 1. Make that a little bigger. Okay, so closed point at 1, 1. Next, I am going to graph my second point at 0, 1. Or, I'm sorry, 0, negative 1. So I have my 2 points plotted. Now I need to draw my line through. The line should be going from the first point through the second point. Whoa. From the first point through the second point all the way to the end of the graph. Okay, we are only graphing this piece of the function. So this should not extend all the way through. I shouldn't have a line that goes all the way from one end of the graph to the other. It should just be going from the first point through the second point to the end of the graph and stop. Okay, there shouldn't be anything to the right of this point. So drawing my line in, and this will not be perfectly straight, but it'll be close enough. Alright. Okay, the second function, looking at my first point, I need to check if this is going to be open or closed. So looking at the inequality, it doesn't have the equal sign. It's going to be an open point at 1, 4. So I go over to 1, up to positive 4, plot my point. It needs to be open. And then the second point is at 2, 7. The second point's always closed. So then again, drawing my line from my first point through my second point to the end of the graph. Okay, I see a lot of people making the mistake of drawing it through all the way to the end of the graph here, like drawing a straight line and a straight line, and they end up with an X. That should not be happening. You should only be drawing a piece of each line. That's why we call it a piecewise function. Okay, and that's all. Next, we're looking at graphing an absolute value equation. So to graph an absolute value equation, we start by finding our vertex. So the vertex for this one, remember we take the opposite of the inside of the absolute value, and then whatever number's on the outside. So our vertex is going to be at negative 4, negative 3. And I'm going to go ahead and plot that point. Okay, next I'm going to figure out what my slope is. And the slope is given to us by whatever the compression or the stretch is. So the number that's in front of the absolute value. So that's going to be 2 over 3. It's already written as a rise over a run. So I am going to plot my next few points. Starting from my vertex, we're going to go up 2 and over 3 using this. Up 2 over 3, up 2 over 3, up 2 over 3, and so on. So I'm going to go ahead and plot those points. Okay, so this is an absolute value function, so that means that my next few points, to find them, I'm going to use my axis of symmetry. So that's the line that goes through the vertex. All I need to do is take all the points that I graphed on the right side, and I'm going to reflect them over the axis of symmetry. So for this first point, it looks like I'm 3 spaces away. I'm going to go 3 spaces to the left, then plot that point. For the second one, if we're even able to do it, looks like I'm 6 spaces away, so 3, 6, plot the point right there. Okay, and it doesn't look like I'll be able to reflect any of the other points. So now I am ready to draw in my line. And if it's possible, we use a straight edge for this. Unfortunately, I'm not going to be able to use one. So my line, that looks terrible. Let's try that again. It's a little better. Oh. Okay. So there's our absolute value function. Make sure you are extending your lines all the way to the end of the graph and putting arrows on the end. Alright, next we're graphing an inequality. So this is with 2 variables. So we graph this like we're graphing an equation. We start by graphing the y-intercept. So the y-intercept is -6. Well, first we want to make sure it's in y equals mx plus b form, which it is. Okay, so make sure that it's in that form. If it's not, you'll isolate the y. So for this one, it's already in the form for us. We're going to go ahead and plot -6 on the y-axis then. So I'm going to go down 2, 4, 6, plot the point. Okay, next I use my slope to find my next few points. So my slope in this case, there isn't a number written in front of the x. If there's not a number there, that means that the slope is just 1. And remember, if we have a whole number, we have to put it over 1. So starting from -6, I'm going to go up 1 over 1, plot a point, up 1 over 1, plot a point, up 1 over 1, and so on. Okay. And then I need to decide if my line is going to be a dashed line or a solid line. And I look at my inequality to determine that. It's a less than or equal to. When it has that equal symbol, that means it's solid. If it doesn't have the equal symbol, that is when it is dashed. So this one will be a dashed or a solid line. So I'm just going to go ahead and draw my line. Okay, and then finally for an inequality, we do have to write or shade in one of the sides. So since this is a less than symbol, I am going to shade everything below the line. A second way to determine that is to use a test point. So if I wanted to, I could choose 0, 0, usually the easiest point to choose, and I would test that by plugging it into the inequality. So if I plugged 0, 0 in, I end up with 0 is less than or equal to -6. That is an untrue statement. 0 is not less than or equal to -6. So that means I would shade the opposite side in. I used this as a test point. It wasn't true, so I would shade this side in. And I would already know that just by looking at the inequality. Y is less than or equal to. Less than means we shade in below. Greater than is when we shade in above. Alright, so just shading that all in. And we are done. Okay, and then last, graphing the absolute value inequality. Graphing the absolute value inequality. We start by graphing it like we graph a normal absolute value function. So figure out what our vertex is. So in this case, we do not have a number on the inside of the absolute value. If there's no number being added or subtracted inside, that means it's a 0. Same thing as if we didn't have a number on the outside. So say this 4 was not here. That means that our k, our y value, would also just be 0. Okay? So anytime there isn't a number on the inside, the x value is 0. If there's not a number on the outside, y value is 0. So in this case, though, we do have a number on the outside. It's +4, so my y value will be +4. So I'm going to go ahead and plot my point at 0, 4. And then next I'm going to look at my compression or my stretch. Remember the negative sign, that means that it's a reflection over the x-axis. So this is going to be an upside down V. And then the compression or stretch is a 2. So I am going to use this as my slope. And I'm just going to put it over 1. So this is my rise over my run. So I'm going to go down 2 to the right 1, starting from my vertex. Down 2 to the right 1, I'll plot a point. Down 2 to the right 1, down 2 to the right 1, and so on. And I'll continue plotting my points. Okay. To plot the other points, remember we need our axis of symmetry, so we are going to just kind of draw it in here. Axis of symmetry goes through the vertex. And then I just need to take my points and reflect them over that axis. So this point is 1 space away from my axis of symmetry. I'm going to go 1 space in the other direction, plot a point. Okay, my next point down is 2 spaces away, so I'm going to go 2 spaces to the left, plot my point. And then I'm going to do the same thing for the others. So this should be perfectly symmetrical. Okay. And then we need to draw in the line, but this is an inequality, so that means that it could be a dashed line, it could be a solid line. We look at the inequality. It doesn't have the equal sign, so that means that this is dashed. So I will draw a dashed line. Okay, and then finally for an inequality, we do have to shade, so we choose which side to shade. Looking at the inequality, y is greater than. If it's greater than, we shade everything above the line. Second way to determine that, if I wanted to use a test point, I would take, say I wanted to use 0, 0, best point to use. If I took 0, 0 and I plugged it in, 0 is greater than -2 times the absolute value of 0 plus 4. So I end up with 0 is greater than 4, which is not true. So that means that I would shade in the opposite side. So this was my test point. It was untrue, so instead of shading here, I would shade the other side, which is exactly what we did. So 2 different ways to do it. Use a test point or look at the inequality. If it's greater than, we shade above the line. If it's a less than, we shade below. Okay, so that wraps up the first part of the review. The second part of the review will be on Edmodo and Google Classroom tomorrow. This is a very, very good tool to use to study for the test, because a lot of the problems are very similar to those that were on the test.